Hi, good morning. Today we are doing algebra lesson number 1, that is linear equation in two variables. Now what do you mean by linear equation? An equation which contains two variables and the degree of each term containing the variable is 1. So now this you studied in polynomials that variable x and y, when the degree is 1, then it is called as a linear equation in two variables. The general form of a linear equation is ax plus by plus c is equal to 0. Now where a, b, c are real numbers, but a and b cannot be 0 at the same time. In other words, they cannot be 0 because if a becomes 0, the entire x term becomes 0. If b is 0, then the entire y term becomes 0. So just it remains a linear equation in one variable. Now on page 1 of your textbook, you have an activity where you have to identify whether it's a linear equation in two variables. Now I'm just keeping my hand on the answers, where I can see that the first one is 4m plus 3n is 12, where variables are m and n and the degree of each of the variable is 1. So yes, it is a linear equation. Moving to the second one, I can see the first variable is x, but the power is 2, so the degree is 2. So sorry, it is not a linear equation. Third one, again I can see the variable x and y, the degree of both of them is 1. So yes. Moving on to the fourth one, 0x plus 6y minus 3 is equal to 0. If you see the x term becomes 0, now then it becomes a linear equation in one variable. Hence it is not a linear equation in two variables. Next one is 0.3x plus 0y. Again a 0y has come. So if I just cancel this, it is going to be linear equation in one variable. So no. If I take the sixth example, it is 4 upon x plus 5 upon y is equal to 4. But when I take indices rule, if I take the x up, it becomes minus 1. And again, sorry, both I take x and y up, it is minus 1. So the degree is not 1, hence it is not a linear equation. If I come to the seventh example, where the first monomial x and y, there are degree 1 for x, degree y, we have 1 for y2. So the degree of this monomial becomes 2, hence it is not a linear equation in two variables. Now page 2, you have one solved example like what you have done last year. A linear equation where you have 5x minus 3y is equal to 8, 3x plus y is equal to 2. Now we studied how to solve this. Now to solve this, you have to make one of the variable coefficient should be the same. Now to make the coefficient same, what we do is we multiply. I can see a 5, I can see a 3. So there are two options. I multiply the first equation by 3, so that becomes 15. Multiply the second equation by 5, so that it becomes 15. But to it's two things to be done at a time. So I prefer to take the second one. In the first equation, I have 3 along with y. The second equation, I have a coefficient 1. So I have decided to multiply the second equation by 3. So what happens now? It becomes 9x plus 3y is equal to 6. You multiply the whole equation, and this is the third equation now. We bring down the first equation, 5x minus 3y is equal to 8, the first equation. And we can see that the signs are different. So we can just add equation number 3 with equation number 1. You can just put this in bracket for the safer side to understand it better. Right. So this becomes 14x, the plus 3y minus 3y gets cancelled. 8 plus 6 is 14. So the value of x is equal to 1. Now you know, once you've got the value of x, we will substitute the value of x is equal to 1 in equation number whichever you like. I prefer the second equation. You can even put it in the first equation. So 3 into 1 plus y is equal to 2. So y is equal to 2 minus 3 and y is equal to minus 1. We have taken the 3 on the other side. The 2 remains on the same side. Thus, you have got the value of x and y. Now you have to write like that. X comma y, which is equal to 1 comma minus 1 is the solution of the equation. Similarly, now come to the second example, which is on page number 3 of your textbook. I can see again here a 5 and a 3 with x and 2, and here I have no coefficient. So you know what you're going to do now. We'll multiply equation number 2 with 2 so that they become with the same coefficient. It becomes 10x minus 2y is equal to 18 2s, which is 36, equation number 3. You multiply the entire equation. Now bring down the equation number 1 down here. So 3x plus 2y is equal to 29. This is your equation number 1. Again, we are going to do the same thing because the signs are opposite. We are going to add. If the signs are same, we are going to subtract. I'll show you in some other example. So this becomes 13x and this becomes 15 and this is 65. So x is equal to 5. Now we substitute the value of x is equal to 5 in equation number 1 here if you want. So just to show you 1, it is 3 into 5 plus 2y is equal to 29. So 2y is equal to, put a therefore sign there, 29 minus 15. Where did you get the 15? Came on the left hand side. Therefore 2y is equal to, I can subtract it, I get a 14, and y is equal to 7. So the solution x comma y is going to be 7 comma 5 is the solution of the given simultaneous equation. So this is how we are going to solve the first exercise. The third example, you can take the fourth example which is there in the third example is an activity based, which you can solve it by yourself. And now I'm going to start with exercise 1.1.